check, 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 check. Check, 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 check. Okay, good afternoon, everyone. Okay, is it the same people who were there in the morning, but lesser are there, no? What happened to the other kidnapped? Huh? Dance practice. Oh, okay, I guess that's more important, right? All right. So we'll continue, everybody. We'll continue with now we'll go to merge sort. But before going to merge sort, there are 2-3 different concepts we need to know before going to merge sort. So we'll try to finish those now. If we are not able to do that, we'll continue tomorrow, but we'll try to finish some of those now. Okay. So first thing we want to do is we've been talking so much about sorting. There is one algorithm that we need to learn, which is 1 second. Yeah, let them come in. Okay. All right. So we'll wait 2 minutes till some more people are coming. Okay, shall we begin? Is everybody here? Okay, I don't know the other people. We'll just, if they come, then we'll pause for a bit. Okay. So we said we're going to do two things. Let's start with one, which is merging two sorted lists. Okay, so listen carefully. You have two lists which are sorted. Come quickly. Come quickly. Quickly. Okay. Quickly, and don't make any noise. Quickly settle down. Okay. So you have two sorted lists. Okay, lists are already sorted and you want to merge them. So there are two lists already sorted and you wish to merge them such that the resultant is also already sorted. Meaning, if I have A, which is like 1, 4, 10, 15, 18. Okay. And then you have another one, which is B, which is equal to 2, 3, 6, 8, 11. Okay. I want a C, which is a combination of A and B. I want a C, which is a combination of A and B, meaning how many elements will be there in C? How many elements will be there in C? How many? 10 elements will be there because A has 5 elements, B has 5 elements. So C will have 10 elements. C itself should be sorted. So I want all the elements of A, all the elements of B. I want all of them in C, and C itself should be sorted. So can you give me the answer? What will C be? What will be the value in C? 1, 2, 3, 4, 6, 8, 10. Okay. So this is C. Combination of both A and B, and C also is sorted. Okay. Now, how do we do this? Think about it. Any thoughts? What is the logic of doing this? I don't want Python code. I just want logic because you all were able to do it. Right? You give the answer right now. C will be 1, 2, 3, 4, 6, 8, all the way till 18. You have given the answer. How did you come with this answer? What is the logic to get this C? How do we arrive at the C? How do we find the C? Yes, everyone? One magical genie or someone came to your mind and told you the answer? How you came up with this answer? You only gave the answer, no, right now. How you gave? How to find that C? Hmm? Quickly, 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 come, come. How to find the C? Come on, everyone. Okay, shall we resume this on Friday? Hmm? I'll resume this on Friday then, this part, okay? Then, why are you not answering? You only gave the answer, and how you have come the answer, I'm asking. Simple, no? Then, A and what did you do with A and B? Sorry? Hmm? Adding it. 1 plus 2 equal to 3, 4 plus 3, 7, like that. Then, louder, merging. Okay, how did you merge? I'm asking. I know you merge. How you merge? Ascending order, yes. But how did you know I choose 1, then I'll choose 2, then I'll choose 3? How did you choose that? Sorting? You use bubble sort? Then you swap the elements. Which elements you swapped? 1, 12. Which any swapping happened here? Okay. You first said 1. Why you said 1 here first? Least number. Least number between what two number you compared? 2 and 1 you compared. Why you compared only 2 and 1? Why didn't you compare 3 and 1 and 4 and 1? Because A is already sorted, B is already sorted, 2 is the least number here. If 1 is less than 2, then 1 is already less than 3 and 6 and 8 and 11, correct? So you chose 1 here, okay. Next, why you chose 2 after that? 2 is less than 3 and 2 is less than 4. But why are you comparing 2 with 4? Why not 2 with 1? 1 is already one is already used, not sorted. Sorted means sorted, everything is sorted. 1 is already used. 1 already used. So what you're doing? Earlier you compared 1 with 2. Next you are not comparing 1 and 2 again. You are comparing 2 and 4. Okay. Meaning what? You are keeping, let's say, one pointer here. I'll say this is not C++ pointer. Okay. Don't worry about it. Simple. This is I over here, and there is a, let's say, J over here. First, you compared 1 and 2. Between that, which is lesser, 1 is there. So, because it already used, you will say I will go to 4 now. 1 is used. Now, anybody else wants to compare with 4. Now, 2 will be compared with 2 is compared with 4. 2 is not compared with 3. 2 will always be less than 3. It's in the same array. Right? So, 2 is compared with 4. Which is lesser among them? Between 2 and 4, 3 is lesser. Huh? 2. So I do 2 here and this goes to 3. Now what will I compare? 3 and 4. Which is lesser? 3. So now this J will go to 6. Between 4 and 6, which is lesser? 4. So I'll use 4 and I'll go to 10. Between 6 and 10, which is lesser? 6. Okay. Goes to 8. Between 8 and 10? 8. Between 10 and 11? Between 15 and 11? Okay. Now there is nothing left to compare. What do I compare 15 with? What should I compare 15 with? Should I compare? It's already sorted. Why will I compare 15 with 18? Anytime 18 will be less than 15? Possible? Then what should I do with 15 now? It's already sorted, so I should leave it. So this is my answer. Up till 11, that's it. Then 18 should come here. Then what? 15. But I'm not comparing with anything you're saying. When one of the other array is finished, simply take the remaining array and copy it as it is. See, 11 is less than 15. Correct? And with that, B array is completed. B array is complete. Whatever is remaining A array will anyways be greater than B array. Yes or no? Anything remaining in A, because 15 is greater than 11, even if there are 100 numbers on the right side of 15, all 100 numbers will be greater than 11. Yes or no? Is it possible there is number on right side of 15 which is less than 11? Why? It is given A is sorted array. It's given A is sorted. On right side of A, you will only have, or right side of 15, you will only have numbers greater than or equal to 15. So if 15 is greater than 11, then automatically 18 will also be greater than 11. Meaning, once you finish one list, You finished one list. Simply copy the remaining list as it is, 15, 18. This is how we are merging two sorted lists. Okay? Understood? Now, if you give me one line answer after this, not one line, one word answer. How you made C? Sir, sorting. Sir, how you did C? Sir, merging. What are these one word answers? You're engineers. Don't give these one word answers. Better answers than that I will get from inter students. Okay? Don't give me these one word answers. Sir, merging. Sir, C. Sir, A. Sir, B. This is not multiple choice question. In interview, if you say like this, you will be disqualified for sure. You all can describe, you all got the answer. The answer, you only gave me that answer. It was correct answer. How to describe that answer is what will get you a job. All right. Cool. So now let's learn how to actually write this function in Python. Okay. So what we'll do is we'll take two arrays. Excuse me. All right. So let's take two lists. One is list A, another is list B. Okay, I'll write a function now. You all remember functions and methods? Remember or not? How to write a function? Which keyword to use? Def. Very good. Def merge. I'm going to take two arrays merge and I'm going to return another array which is merging of both A and B. So we'll call that function, but first let's complete this. Okay. So we'll take a pointer I for A. It starts at 0. For J for B. Okay. I and J we are taken. And what we'll do is we will write a while loop. Okay. And we'll keep comparing I value of or A of I with B of J. That's what we're comparing. A of I. That's what we did here, right? A of I and B of J we are comparing. We'll keep comparing A of I with B of J. Okay. Yeah. So we'll compare A of I with B of J. And when should we stop comparing, everyone? When should we stop comparing? When is it that we stop comparing? Anybody? When did you stop comparing here? After the completion of list. Either A will complete or B will complete. One of the list will complete. So while A less than len of A and B or J less than len of B. So while both of them are not completed, you keep comparing. While either of them, if either of them complete, then this loop will break. Understood this condition, everyone? If I becomes equal to len of A, means I has completed, or J becomes equal to len of B means B has completed. If either one of them completes, then you will stop comparing and just copy the remaining list. If A of I is less than B of J. Okay, we forgot to do one thing. We also need an array C, a list C. Okay. So if A of I, and this will have the merging in it. So if A of I is less than B of J, which one should we use now? If A of I is less than B of J, which one should we use? A of I. So I will do C dot append A of I. Add this at the end of C. Else, what should we use? What else is there to use? B of J. C dot append B of J. Okay. Now, when will this while loop break? Oh, we should also do one more thing. We should do I equals to I plus 1 and J equals to J plus 1, because once you add it, it should go further. Okay. Now, when will this while loop break, everybody? When will this while loop finish? When condition is false. Very good. When will the condition become false? I equals to len of A or J equals len of B. One of them. Okay. One of them when they are finished. Now, which one is finished? How do we know? In our example, J finished first. It's very possible that I can finish first. Correct? Possible, right? So how do we know which one is finishing when? What we do is, we don't worry. We check which one has finished. So I'll say while I less than len of A. Now tell me this, everybody. If I has finished, if I is already equal to len of A, will it even enter this loop? Is the question too difficult? Very, very difficult question I asked. Okay, difficult question. Okay. My question is, if I equal to len of A, meaning of I equal to len of A, what does that mean? What does mean I equal to len of A? Means A is, boys, I equal to len of A. What does that mean? Length of array A is assigned to I. Very good. Means I started from 0. Correct? It equal to len of A means, okay. Let's go very, very simply. Can you, boys, only boys, I think you guys have not revised. Girls have at least revised a little bit. Boys, what is the first index over here? What is the index of 1? 0. Very good. 4, 1. Then 2, 3, 4. Here 0, 1, 2, 3, 4. What I am doing, I am starting I like this. I is over here and J is over here. Okay. I compared 1 with 2. Which is lesser? Only boys. 1 with 2 compared. Which is lesser? 1. So what I did, I used 1 here, and then what I did? I will move forward. How to move I forward? What is value of I right now? Value of I is 0. A of I is 0. Value of I is 0. A of I is 1. Again, boys, tell me. I is equal to A of I is 1. 1 is less than 2. So I put 1 in C. Then what do I do with I? Move forward. How to move forward? How to move forward, boys? Come on. I is equal to I plus 1. I is equal to I plus 1. So what is value of I right now? 1. Very good. Now I compare A of I. What is A of I? What is B of J? Which is lesser? 2 is lesser. So what will happen? I will use 2 here, and then J equals to J plus 1. Meaning J will now become 1. Then after that, between 4 and 3, which is used? 3. So which one will move forward? J or I? J. Then between I and J, which will move forward? I. Then between I and j, which will move forward. Then I. Then j. Okay. Now what do we do? Copy the remaining part. Which means when did we start copying? After completing. How to know it's completed? When j stops what? When j value is equal to your name? Pradeep. Again, Pradeep. Round of applause for Pradeep. Very good. What did he say? How to know that array has completed? When j value is equal to length of array. Why? What is the last index of any array? N minus 1. What is n? Length of array. So length of array minus 1 will be the last index. If I reach length of array, means what does it mean when I reach length of array? He just said it. What happened? English is very difficult for you all. Then if j is equal to length of array, what does that mean? The elements are over. We have finished all the indexes. Okay. So why I asked all this was, when I equal to len A or j equal to len B, either of these two conditions, you know meaning of either? What is meaning of either? One or the other. Understood, no? If either I equals len A or j equals len B, this condition will bring. Condition will finish or not finish? Yes. What is meaning of that? Code fine. What is meaning of that? It means either I completed array A or j completed array B. Correct? Agreed, boys? Completely agreed on this part? Yes. Meaning whichever is complete, good. Other one which is incomplete should be copied. Yes or no? I need to find out which one is complete or incomplete. Complete, what will I do by finding complete? If it's complete, very good, we can clap. Incomplete is the one we'll copy. Yes or no? Right? So, what I'm trying to do is, I want to find out which one is remaining. Is I remaining or j remaining? So, what I'll do is, I'll say, let me try to copy I. I can only copy I if it is still less than index A, still less than the length of A. Yes or no? So, I'll say C dot append A of I is equal to I plus 1. Now, if I was completed, will it even enter this while loop? If I was completed, will it enter this while loop? Boys, understood or not? Only 4-5 are understanding. What it means if I is completed? Just 2 minutes back, rewind. What it means if I is completed? There is no element to complete. Very good. What will be the value of I? Length of array. Will it enter this loop if it is equal to length of array? Will it enter? No, because I will be equal to len A. This will enter only if it is less than len A. Okay. So if I is remaining, this loop will execute. While excuse me, while j less than len B. Now you'll say, sir, why we are copying both? We are not copying both. We are copying only the one that is remaining. We don't know which one is remaining. So we are saying if I is remaining, this will execute. If I is not remaining, it will skip this. And if J is remaining, we will append B of J and we'll do J is equal to J plus 1. Okay. Now, if both are remaining, is it possible both are remaining? Why is it not? Why is it possible? Why is it not possible that both are remaining? If both are remaining, is it possible? Yes or no? No. Why no? Why no? Comparison. What about comparison? Notebook, yeah. You're looking very, very angrily. What happened? Did I say something bad to you? You only first. You're okay, no? Very angrily you're looking. What happened? You want to hit somebody? All good, though? And you're giving comments to him. Then what did we say? One of them is incomplete. My simple, humble question to you all: why both can't be incomplete? It is in the answer is here only in front of you. Answer is in front of you. You just have to tell me. Okay, keep thinking. I want answer. Everybody understood the question? No? Who did not understand the question? Could you just raise your hand? Who did not understand the question? Okay, who all understood the question? Can you raise the hand? Understood question. Who all are here who are just watching entertainment? Sir is there, he's speaking something, we just have to listen and copy in our notebook. Yes? Any use of me coming here? I can do this online also, no? Right, everybody? Any use of me coming here, standing in front of you? Okay. What was the question? What is the question? We said if I is incomplete, this will execute. If J is incomplete, this will execute. Both of them cannot execute because both of them will not be incomplete. My question is why both of them will not be incomplete? Now understood the question? Should I repeat the question? Yes? Okay. Again, let me repeat the question. When will this while loop execute? When this while loop will execute? I is less than len A. When this while loop will execute? J is less than len B. What is the purpose of these two while loops? To copy the remaining elements. My question to you is it possible that both of them have remaining elements? Yes or no? No. Why no? Almost there. Keep thinking. Both of them are sorted. Now I'm telling you both are sorted. It is given the two lists are sorted. Anybody with the answer? Yeah, please. Sure, you can explain from there also. Or you can come and explain, no problem. Yes. Yeah. This is not sorted area, but okay.
When we compare both of them,
Yes.
it will be first time
Right.
when we compare these three, this is the bigger than value than this time. This is the bigger value than this. When we compare the elements in the right side of the image, it is already sorted. While this is mixing.
Relax. You're doing good. Very good, actually. The example is very correct. I know what you're trying to say. Just say it now.
Any values compared with then comparing, it will be greater than and one will be less than. When the value is greater than, if when the in at the end of list, the smaller value when compared to the first list, it will be added to the
Correct. Yes.
list.
Yes.
Then this will be remained.
So you're saying basically either the maximum value of this will be greater than all of them,
Yes.
or maximum value of this will be greater than all of them. It is but natural. It's that has to be the case, right? Either this 130 is greater than all of these, or this 120 is greater than all of this. That is the case. If 120 is greater than all of these, then all of this will be merged. So that means B is completed. If 130 is greater than all of these, then all of these will be merged. Means A is completed, B is remaining. That's what it is. It's correct. Your answer is correct. There is an even easier answer. I'll tell you. Okay, but your answer is correct. So again, there is one student who is really coding and understanding. He's given all the answers since morning. Others, very, very, very simple answer. And I told you it's already in front of you. Okay, I'll tell you. What did I say? What if both I is less than A and J is less than B? Okay. If both are there, then why this loop even exited? First loop, if I is still incomplete and J is still incomplete, then will this first loop exit? Will this loop complete? When do we finish this loop? When do we finish this loop? Either I is equal to len A or J is equal to len B. Meaning, if you have finished this loop, you are guaranteed that one of these is false. You are guaranteed that. Understood? Otherwise, it will never exit this loop. Simple no. Understood this point or not? Yes or no? Okay. So this is how you merge. So that's it actually. That's all you need to do to merge two arrays, two lists. And then we'll finally return C. Okay. And here we'll say C is equal to merge A, comma B, print so is this the merging of A and B? Is it correct answer? Yes or no? Yes. Okay. Please take this code. Very, very important. Merging two sorted lists. Nothing. Nothing happened. I'm just waiting for them to write. Done, everyone? Yes? Okay. So, so this is for merging two Merging two sorted list. Yeah, it happens. You're all engineers, right? You'll make a lot of mistakes like this. Don't worry. Yeah, we'll fix it. All good? Okay, hopefully. All right. So, yeah, so this was merging two sorted lists. Now, before we go on, we will need to learn one more interesting algorithm before we can take up merge sort. Okay. And that algorithm is called as recursion. Anybody heard of recursion? No? Yes or no? What is recursion? What you heard of it? No problem if you heard wrong thing also. What you heard of it? Calling itself. Very nice. Okay. Function calling itself. That is called as recursion. In fact, let me see. Let me see if there's a recursion meme I can show you. And do you understand this? You have three wishes. So this guy asks for four wishes. I don't want three wishes, I want four wishes. Okay. Says granted. And he says, now you have three wishes. You get what I'm saying? Because he said, you have three. I said, I want four. Okay. So I'll grant you this wish. Now you have three again. Or something like this, where I learn to program, make a recursive function, and then again start calling the same thing. Let me see if I can get another one. There is a good recursion meme somewhere. Yeah, this one. This one is better. I like this one. Anybody know this cartoon? Anybody knows this cartoon? Huh? Which one? Pooh Bear, Winnie the Pooh. Okay. So Winnie the Pooh is there. Tigger is there. He's saying, that's not honey. You're eating recursion. And recursion is basically calling itself. So it's the same cartoon, but again over here. Okay. So that's what recursion is. Hopefully you will be able to understand it today. What happens in recursion is, you're right, you call the same function again. You call the same function again, but not to do the same activity. This is the important thing. It's not to do the same thing, it's to do the same procedure but with different values. You will call recursion to do the same procedure but with different values. Simplest example is, let's look at factorial. How to calculate factorial of n? If there is n, how do I calculate factorial of n? N into, that's it. Okay. So n factorial, the simpler way of writing in factorial is 1 into 2 into 3 into 4 into all the way till n, which is also called as, you can also write n factorial as n into n minus 1 into n minus 2 into all the way till 1, which you can also write as n factorial is equal to n into n minus 1 factorial. Clear, everybody? So what does it mean? I'm saying to calculate factorial, I'm saying multiply n with the factorial of it one lesser number. Now, when I say something like this, Let's say I say 3 factorial is equal to 3 into 2 factorial. So I have to now calculate 2 factorial. 2 factorial is equal to 2 into 1 factorial. So I have to calculate 1 factorial. 1 factorial is equal to 1 into 0 factorial. So I should calculate 0 factorial now. 0 factorial is equal to 0 into minus 1 factorial. Is this correct? No. Why is it not correct? Up to 1. After 1, we don't take factorial. Very good. Actually, not after 1. After 0, we don't take factorial. 0 factorial is 1. By definition, 0 factorial is not calculated. By definition, 0 factorial is 1. That's it. We don't go below that. This case is called as the base case. Meaning, at all other, even if you did 100 factorial, it will be 100 into 99 factorial. 99 factorial will be 99 into 98. At all other cases, you will do n into n minus 1 factorial. But there is a limit. You will come to a limit, and at that limit, it's going to be just 1. The 0 factorial is 1. After that, you are not going to recurse further. That limit is called as base case. That limit is called as the base case. All the other cases are called as recursive cases. All the other cases, right? 2 factorial, 3 factorial, 4 factorial, all of them are called as, what are they called as? Recursive case. So all this is recursive case. Okay, and all of the other ones also. Now, if I want to define this in terms of, Python functions, let's just define the recursive case and see what happens. Okay, I'll say define factorial, define factorial of some n. And what did we say? It will be, what will it be? Factorial of n recursively. What I was just like 1 minute before I said n into n minus 1 factorial. Very good. So I'll say, let me see, print, not print, let's say answer is equal to n into factorial of n minus 1. Okay. Now, if I did just this, and I'll say return answer. Okay. And I'll say n is equal to 5. Answer is equal to, or rather, x is equal to factorial of n, print x. So I want to find out 5 factorial. What will be the answer of 5 factorial? 120. Very good. So let's see what's happening, everybody. What's happening is, I'll also print here, print factorial of n, finding factorial of n. So we're trying to find the factorial of n over here. I just want to show you what's working. See, it's continuously going into negative. Let's start from the beginning. What does it say? Factorial of, finding factorial of, okay, 1 second. It went to -4. Although it should say, should start from 5, but hold on. Okay, so the output is this, everybody. First, look at it here. What happened? N is, everybody pay attention here. N is 5. I said, let's find factorial of 5. So it goes here and prints finding factorial of 5. This is what it prints. Then it says answer is 5 into factorial of n minus 1. What is n minus 1 in this case? 5 minus 1, which is 4. So now it calls the same function again, but the value of n is now 4. It says finding factorial of 4. Okay. And then it says 4 into factorial of 3. Factorial of 3, it will again call the same function and say finding factorial of 3. Then it will try to find factorial of 2, of 1, of 0, of minus 1, of minus 2. So it's not stopping. It's not stopping. It's continuously trying to find the factorial again and again and again. We have to stop somewhere. Where should we stop it? We should stop it at 0. So instead of doing recursive case again, this is the important part, everybody. What you will do is, whenever you have to write the base case, always base case is written at the top. Even though it's the last to be executed, we write it at the top. So I'll say if n equal to 0, don't again call recursion. You simply return 1. If n is 0, factorial of 0 is 1. Don't go again into recursion. Simply again return 1. Now let's see what happens. So it says, I'm trying to first find, look at it here, n is 5, factorial of 5. It will go to factorial of 5. It will go here and it will say, is 5 equal to 0? No. So it will say finding factorial of 5. 5 into, what will it do? 5 into factorial of 4. Is 4 equal to 0? No. So it will say finding factorial of 4. Then it will do 4 into factorial of 3. It will say finding factorial of 3. Then finding factorial of 2. Then of 1. So what's happening here is something like this. First, it's saying factorial of 5. To do factorial of 5, it should do 5 into factorial of 4. Oh, so I have to calculate factorial of 4. Okay. 4 into factorial of 3. Says okay. 3 into factorial of 2. 2 into factorial of 1. 1 into factorial of 0. If we did not write that base case, it will continue. But we wrote base case here. What did we write? If n equal to 0, don't go forward. Simply return 1. So it says, oh, factorial of 0 you want? That's 1. Oh, so 1 into 1 is 1. I can return back because factorial 1 was called. So I can return back and say 2 into 1 is, sorry, 1 into 1 is 1. Now this factorial 2, which was 2 into 1, can be returned as 2. Factorial 3, which was 3 into 2, can be returned now as 6. Factorial 4, which was 4 into 6, can be returned now as 24. And factorial 5 will then be 120. This is what you call as recursion. Okay. This is what we call as recursion. Now this print statement I wrote just for us to find, but I'll remove that. Simply for n equal to 5, the recursive is 120. The factorial is 120. Write this down. Write this down, everyone. written it down quickly? It's not that much. Okay. Those of you who written it down, do you know Fibonacci series? Meaning not the code. Do you understand Fibonacci series? What are the values of Fibonacci series? 0, 1, 1, 2, 3, 5, then? Okay. This is Fibonacci series, everybody. Let me just open it. Fibonacci series is the sum of the previous two numbers. 0 and 1 are the starting two numbers. Every number after this is the sum of the previous two numbers. So what are the previous two numbers here? 1 and 0. If you sum them, what will happen? 1. Then after this, 2. Then 2 plus 1, 3 plus 2. Then okay, and so on. In your own notebooks, please write the recursive way of finding Fibonacci series. Please find the recursive way of finding Fibonacci series. Base case being 0 and 1 over here. Meaning that if I ask you, simple as this, if I ask you Fibonacci of 0, your answer should be 0. Fibonacci of 1, answer should be 1. Fibonacci of 2, what should your answer be? Fibonacci of 2, 1. Fibonacci of 3, 2. Fibonacci of 4, 3. Fibonacci of 5. Fibonacci of 6. Okay. So this is the 0th Fibonacci number. This is 1, 2, 3, 4, 5, 6, like that. So given n, you should give me the nth Fibonacci number starting from 0. Write the recursive function for it. Write out, everybody. Please write the recursive function for it in your own notebooks. Done? Sure. Done? You completed? Then right? Completed? Sure. Yeah. Come. Sure. Show me. Yeah. Hmm? Yes. Here is the answer. Completed. You know the question? What is the question? Huh? Fibonacci series in recursive. Okay, what you're dreaming or what? What is the question, everybody? Right? Recursive way of finding Fibonacci series. Very good. Anybody done? Anybody got the answer? Okay. So first thing to remember, everybody, is to find the recursive relation. Like in factorial, we found n into factorial n minus 1. Can you find such a relation for Fibonacci? Is there such a relation for Fibonacci? Meaning to say, can I say something about Fibonacci of n? What does it depend on? How to calculate Fibonacci of n in terms of its previous numbers? Yes? Fibonacci, yes? Louder, I can't hear you, louder. Very good. Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right? So this is what it is. This will be true for all cases, but there are some base cases. What are the base cases? Fibonacci of 0 will be equal to 0. Fibonacci of 1 will be equal to 1. That's it. Everything else can build from this. So we will say, let's def Fibonacci of n general case. First write the general case or recursive case. Answer is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. And we'll say return answer. But this will go infinitely. We need a way to stop it. When do we stop it? We say if n equal to 0, return 0. If n equal to 1, return 1. In all other cases, just do the recursive case. Now we'll say, let's say n is equal to int input. Let's take input and we say answer is equal to Fibonacci of n, print answer. So if I want to find out Fibonacci of 0, it should say 0. So like that, what I'll do is, for I in range right, we'll just print out all the Fibonacci numbers. Okay, so Fibonacci 0 is 0, Fibonacci 1 is 1, Fibonacci 2 is 1, Fibonacci 3 is 2, 3, 5, 8, 13, 21, 34. Okay, how did it do it? Here we wrote a loop to call the Fibonacci function. What's happening in the Fibonacci function? If n is 0, return 0. If n is 1, return 1. These are the base cases. Let's say, for example, you want to find Fibonacci of 2. So what will happen in the case of Fibonacci of 2? It's going to say Fibonacci of 2 is equal to Fibonacci of 1 plus Fibonacci of 0. Fibonacci of 1 will automatically return 1. Fibonacci of 0 will automatically return 0. So 1 plus 0 is 1. Let's say I did Fibonacci 3. Fibonacci 3. How will it calculate? It will say Fibonacci 2 plus Fibonacci 1. So to calculate Fibonacci 2, it will go and say is equal to Fibonacci 1 plus Fibonacci 0, which is 1. So you will get is equal to 1. And for Fibonacci 1, automatically it will say it's 1, which is equal to 2. Same. Fibonacci 4 is equal to Fibonacci 3 plus Fib of 2. To calculate that, it's going to first here, to calculate Fib of 3, it will say Fib of 2 plus Fib of 1. To calculate Fib of 2, it will say Fib of 1 plus Fib of 0, which will be 1. To calculate Fib 1, it's 1. So you'll get 2 here. Plus, again, to calculate Fib of 2, it will do Fib of 1 plus Fib of 0, which is 1, which is equal to 3. Okay? Understood the recursive way of Fibonacci series? Okay. So what we are going to do is we'll combine two concepts that we learned today, which was merging two sorted arrays. And what's the second concept? Recursion. Combining both these concepts is how we will do merge sort. Okay, that's how we're going to do merge sort. I know time is up right now. I'll not take merge sort right now. Can you give me a quick recap of what all we covered today, everybody, in the second session? Do the quick recap. merging two sorted lists. Recursion. In recursion, there are two cases. What are the cases? No, two cases. No, those are examples. There are two cases in recursion. What are the cases? Base case and recursive case. Very good. What is the example one we saw? Factorial. Example two. Okay, everybody? Clear? Okay. So for tomorrow's session, please try to watch videos of merge sort. If it's locked on EDYST platform, just go to YouTube and watch. There are thousands of videos on merge sort. Right? Please watch the video on merge sort and then come to the session tomorrow. It will be much easier for you. If you come just blindly like that, it will be much more difficult. So please come to the session watching one video of merge sort at least, and try to prepare list of questions you have doubt in. We will have some time for doubt solving tomorrow. Any questions that you have that you want me to solve in the class, let me know. Maybe you are not there in this hall tomorrow. Maybe you will watch it on YouTube. Doesn't matter. You prepare it, share it with your coordinators. I will get it. Okay. Share it with. I'll make sure that I'll ask. It will be on your WhatsApp group. But make sure you give your doubts so that I can collect those doubts and I can solve them in tomorrow's session. Okay. So do share it with the coordinators. I'll tell them to collect the doubts from you. Okay. All right, everybody. Thank you so much. That's it for today. Thank you so much, everyone.